So today we will finish the binary search on 1D arrays. So we'll start with the first problem, which is find out how many times the array has been rotated. Given an array of integer array of size n sorted in ascending order. Okay. Now the array is rotated between 1 to n times, which is unknown. How many times the array has been rotated? So we can go through the example. Now in this situation we can find that it has been repeated 4 times. So the best way I can do is I need to find the unsorted side of the array. Suppose I have the mid at 7. I'm just doing it on the spot right now, but yeah, the mid will be 7 and I'll check whether if it's sorted or not. If it's sorted, then I will go for the next array, second half of the array, and I will check whether the value is um, till the value of low is less than the, what do you call, high in this situation, because it isn't right. If it's true, then I'm gonna take the value of index of uh, low and high, and I can just subtract them and plus 1. So in this say case, 0 1 2 3 4 5 6 7, and in this case 4 minus 7 minus 4, 7 minus 4, which will get 3, and plus 1, so we'll get the value 7. 7 minus 3 plus 1, which is 4. We'll go to check this one as well. We can do this by the same way. I'll check whether the one side is sorted or not. If it's sorted, then I'll go for the other one, and I will check whether this will be my new half, you could say. And in this situation I can say that it's sorted now. So, after it's sorted, then I can just take the value of low to mid and low and high, and then I can just take the value. I can just take the value of low and high, and then I can just subtract mid high minus low plus 1, so which I will get in this situation, which will give me 3. I think that is the approach I can go with. um, let's see, we can code it out somewhere. Okay, find out. Just yeah. We can do something similar to, okay, so let's think on how I can do that. I need to get a pen as well. Okay. Hmm. Okay, the question is different. This is the one. I think yeah, we already did that. Um, okay, we'll just go with this one. Okay, the number of rotations we need for to find the values. Okay. I don't know how we can do that. Okay, I think I just found another solution. We can see that the number of rotations has done is equal to the value of the lowest number, index of the lowest number in the array, as it is a sorted array, right? So instead of finding all the stuff, we can just go through the array and find the lowest value, minimum value, and I can just print it out. So yeah, let's go with that. Public int find lowest val index value index in the sorry list of integer with arr and int of n. Int low equals to 0 and int high equals to -1, while low is less than or equals to high. I'll check. Okay, I need to add the lowest integer value as the lowest val equals to integer dot max value. Yeah, and I need an index for to keep a track of the. Okay, so int made equals to low plus high by 2. Okay, after that, hmm, Okay, I need to find the sorted ones, right? So in that case, if ARR of low, right, less than or equals to ARR of mid, if ARR of low is less than lowest val, then I have to update the value of lowest val to ARR of low, and I need to update the value of n equals to low. Yes, if it's there's no use. Low equals to mid plus 1. Else if error of mid is less than error of high, then I need to update the value of lowest val with error of mid. After that I need to implement the value of end mid. Else I need to update the value of high equals to high, sorry, mid minus 1, mid minus 1, and then I can return mid, sorry, in after this I can just return lowest val index ARR comma ARR dot size. Dot get. I need to take mid over here and low over here, low over here, and what else? Mid, high over here, high, mid over here again, and that is it, I guess. Okay, let's go. I mean, that was pretty easy. I just had to find the index. So we are given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. Okay, so I need to return an element which appears only once in the array. So one of the ways I can do is by using a hash map, and I can just note down the frequency into the hash map, and then I can get the value, key and value. If the value is equals to 1, then I'm just gonna print out the value as 2 in this situation. But as the question has asked us to do it in a big O of or log n and the order of one space, the best way I can do is I need to find a way. Okay, maybe we'll go something with the size. No, sizes cannot matter as well because they are not in continuous array. It's not a continuous array, so I might have to. Hmm. Okay. Just I'll come back again with the solution. I guess. I guess. Yeah. Actually, I forgot to start the recording, but yeah. So what I did right now is I'm trying to take the array from the index 1 to index n minus 2, so that I don't have to check whether the condition, if it's in this situation where 1 is not equals to the previous one and not it is not equal to the right one. So in that case it might go create an exception called index out of bounds. So it's so that to handle that edge case I have created this thing, this statements where it checks for the next element. If it's true that if that it's not equal, then I will get the value as a error of 0 and a error of n minus 1 if this condition passes through. And if the array size is 1, then I'm just gonna print the return the single element available in the array. Now what I'm trying to do is here is I'm creating the loop and binary search basically, and where I'm checking the if the what do you call element is I'll just show you this thing. So if I'll check whether the condition where array of mid is not equal to the left side on the right side. If it's not, then I'll just return the mid value. If it's not, then I'm checking the left index. I'm checking in the left index whether if it's true, then I'm checking the value of mid. If it's even, sorry, if it's odd, then I'll check the value with the minus 1, because odd will precede even, which will have the same element. And if it's not, then I'm going to check the condition where the mid element is even. If it's even, then I will be checking the next succeeding element in the array. And if it's true, then I'm just gonna update the value of low to mid plus 1. And if it's not in that situation, then I'm just gonna decrease the value, because uh, I will be eliminating the right one, eliminating the right half array. I'm still confused about why are you not implementing this code in the right side. And we can do this because yeah, okay. And we are doing this by checking the value if it's low. So if I have it at the even, then I will check the previous one. Suppose if this is mid, I'll check the previous one. It's odd, right? So in this situation, it's odd. So and wait, let me check if it's 10, right? 11. It's fine. So this will be my index 5. If it's not equal to 0, 1 second. I need to check whether if it's valid for this. Yeah, so the this is 5, right? So I'll just get this one and I will check whether mid is equal to the minus 1. Yes, it is equal. Then what I'm doing is, yes, the condition has passed through. So low equals to mid plus 1. Mid plus 1. Why am I doing that? Okay, okay, so basically we need, whenever we have what they call, I'm just gonna notepad. Yeah. So when I have such as E0, 1, 2, 3, 4, right? So in that case, sorry, 0, 0, 1, 1, 1, 1, 2, 2, 3, 3, 4, 5, 5. So as I can see, I have with that even, odd, even, odd, even, odd, right? In the situation, that is how it's working. But when I encounter 4, after that, what happens is my index, such as even, odd, even, odd, even, odd, even, odd, even, and now it becomes odd and even, right? So now it's at odd position and even position. So if suppose if I am at even, I mean my mid is at even, what I'm gonna do is I'm going to check whether the previous element, which was even, right? So the pattern I'm going to follow is the next even will be, the value even will be uh, my pair. If it's true, then I need to check. I mean, I can say that as my the left half follows this pattern of even odd, even odd. So the single element does not exist in the left one. So in the right one, I need to check, and in this situation, I can say that the odd even situation in in this element. I mean, is in this half. So now the low will be at 4 and the high will be at even, and now the odd and even will check whether if its condition is true. Then if it's not, then see, now I can say that yeah, this condition does not exist because the left one is not equals to the mid is not equal to left. So my high will be mid plus 1, low will be same, and now I can check the condition if it's equal to the previous element or the next element. Yeah, so let's check if error of mid equals to error of mid, sorry, error of, sorry, mid minus 1. Okay, not equals to, right, we need to find the one which is not equal. So and error of mid not equals to error of mid plus 1. If it's true, then I can just return the value of error of mid. Yeah, now I have handled this condition. If I need to check whether they're following the pattern of odd even, if it's in the left side, then it will be even odd. So I need to check whether if ARR of mid, I need to check whether if it's even or odd. If it's even, mod 2, right? Mid mod 2 equals to 0, which is even, and ARR of, so if it's even, then my next element will be odd. Next element odd should be which index odd will should be the same number. So I need to check that. So mid plus 1, yeah, equals to ARR of mid, yeah, and or I need to find whether it is mid mod 2 equals to 1, and then I can ARR of mid equals to ARR of mid minus 1. So after finding this, I can update the value of mid, sorry, low equals to mid plus 1, else we can do is high equals to high mid minus 1, mid minus 1. Return minus 1 nums equals to, sorry, what is the name of the function? Single element. Returns element of nums and nums dot length. Yeah. This kind of problem is done as well. We'll go to the last in the 1D array. A peak element is an element that is strictly greater than its neighbor. Given a index 0 integer array, 0 index integer array, find the peak and return its index with 1. Will peaks return the index with any of the peaks? You may imagine that. Okay, peak is an element where find a peak. Element that is strictly greater than its neighbor. Greater than its neighbor. Okay, so basically both of the elements beside the peak should be lower than the value. Hmm. And I should return the index as well. Hmm. How can I do the index? It's something similar to the previous one. Okay, I might have to check for the solution as well. Okay, I have went through some approach and we can find something. I mean, we can do in a way where we'll check the mid if it's greater than both of its neighbor. If it's not, then I'll check the condition where mid is less than mid plus 1. Then I'm going to update the value of low to mid plus 1. And if it's the other way around where mid is less than mid minus 1, then high equals to, and update the high to mid minus 1. I think it should work well. Let's see. Public int peak element in ARR of int n. That's it. That's enough for us. Int low equals to 0, int high equals to n minus 1, while low is less than high. We can do is mid equals to low plus high by 2. Now I'm going to check whether if error of mid is greater than error of mid plus 1 and error of mid greater than error of mid minus 1. If it's true, then I will just return the index right. I need to return the index here. If it's not, then I'll check whether mid is less than error of mid plus 1. In that case, I will update low equals to mid plus 1, else I equals to okay, else if error of I mid less than or equals to error of mid minus 1. In that case, I can just update the value of high equals to high, sorry, mid plus 1 minus 1. Return minus 1. Peak element. Mm-hmm. Hmm. Okay, I need to handle the case. Edge cases as well. If 0 is greater than ARR of 1, so we can just return 1. Sorry, 0. If ARR of n minus 1 is greater than ARR of n minus 2, return n minus 1. Let's start with 1, 2. Forward now. Let's go, let's go. Let's fucking go. I did it on my own.